Okay, so let's continue. We'll look at some examples of taking positive reals to a rational power. So for example, if we are considering 8 power 2 by 3, so 8 power 2 by 3 is 8 power 1 by 3 whole square, right? And 8 power 1 by 3 is that unique positive real which cubes to 8. So that real is 2. So 8 power 1 by 3 is 2. So we need to take 2 square. And this is just 4. Hence 8 power 2 by 3 is 4. So another example. What is, for example, square root 2 power 3 by 4? Square root 2 power 3 by 4 is 2 power half power 3 by 4. And a power r1 power r2 is a power r1 r2, right? So a power 1 by 2 times 3 by 4. So this is just a power 2, so 2 power 1 by 2 times 3 by 4. This is just 2 power 3 by 8, right? So square root 2 power 3 by 4 is 2 power 3 by 8. So another example. What is 25 by 9 power 3 by 2? 25 by 9. What is 25 by 9? 25 by 9 is 9 inverse times 25 power 3 by 2. So 25 by 9 is 9 inverse times 25 and we need to take power 3 by 2. So 9 inverse times 25. So AB power R is A power R B power R, right? So we can write 9 inverse power 3 by 2 times 25 power 3 by 2. So 9 inverse. So we can 9 inverse power 3 by 2. See, it is 9 power minus 3 by 2. So it is 9 power, so minus 3 by 2 and 25 power 3 by 2. Right? And 9 power minus 3 by 2 is 9 power minus 3 or 9 power 1 by 2 power minus 3. We can write it like this. And 25 power 3 by 2, a power m by n is a power 1 by n power m, right? So 25 power 1 by 2 power 3. 9 power 1 by 2 is just 3. So 3 power minus 3 times 25 power 1 by 2 is just 5. So 5 power 3. And 5 cube is 125 and 3 cube is 1 by 27. So the answer is 125 by 27. 25 by 9 power 3 by 2 is 125 by 27. We just use the definition of A by B. So A by B is B inverse A, right? So B inverse A. Then we used A B power R is A power R B power R. And then we used A power m by n is A power 1 by n power m. So that's all we used. And then we got this expression, right? And so these are some basic examples. Another example. Let A be a positive real. So we can ask, what are the solutions of x square equals A? So what are the solutions of this equation? So we can answer this. So note that x square equals A. We can rewrite this as x square equals square root of A whole square, right? Since A is positive, square root of A exists and we can write A as square root of A whole square. So this x square is square root of A whole square. This is same as saying x square minus square root of A whole square is 0. So this is same as saying, so x minus square root of A times x plus square root of A square minus B square is A plus B, A minus B times A plus B. So this product is 0. Saying product of two real numbers is 0 is same as saying x minus, so either one of them, saying AB equals 0 is same as saying A equals 0 or B equals 0, right? Within real numbers. A equals 0 or B equals 0 implies AB equals 0 and AB equals 0 implies one of them must be 0. So we have this. So this happens if and only if x equals root A or x equals minus root A. Hence what we did, x square equals A, we wrote A as root A whole square and brought the x and A terms to the left and factorized it. So we got that x minus root A equals 0 or x plus root A equals 0, which is same as saying x equals root A or x equals minus root A. Hence what did we find? We can rewrite this constraint x square equals A as x equals root A or x equals minus root a. We are given a is positive, hence we can write saying x square equals a is same as saying this statement, that x equals root a or x equals minus root a. So what are the solutions? We have two solutions, right? Hence x square equals a has solutions. These are the only solutions: x equals plus root a and x equals minus root a. I'll write it and x equals minus root a. Right, these are the only solutions of x square equals a. So we know how to solve equations of the form x square equals a where a is positive. When a is negative, anyways x square equals a will not have any real solution. No, there is no real with squares to, for example, minus 1. We'll later see that there are numbers called complex numbers in which we can solve equations of this form. In any case, x square equals a when a is positive, we can rewrite the statement x square equals a as x equals root a or x equals minus root a. Hence x square equals a. The equation x square equals a has the solutions, and the only solutions x equals plus root a and x equals minus root a. So another basic example. So consider the quotient 1 over root 2. So we can ask, can we express it as a quotient where the denominator is rational? We saw that square root of 2 is irrational, right? So can we change this quotient 1 by root 2 to a quotient where the denominator at least is rational? So we can do that. So what we can do is, so note that we have 1 by root 2. 1 by root 2 is just 1 by root 2 times root 2 by root 2. We are multiplying by 1. So the exact algebra what we are doing is 1 by root 2 is, so 1 by root 2, so root 2 inverse times 1, right? So 1 by root 2 is root 2 inverse times 1, a by b for any reals a and b where b is not equal. This is what we mean. So we are just writing this as or I'll just write a by b equals am by bm, because a by b is what? Just b inverse a, and am by bm is what? Am by bm for m not equal to 0. We can write a by b as am by bm. This is because a by b is b inverse a and am by bm is by definition bm inverse am. So bm inverse we know is b inverse m inverse and am. So m inverse and m, they multiply to 1. So this is also b inverse m. Hence a by b is am by bm. We can always, like we dealt with rational numbers, we can deal with ratios of real numbers like this. Hence let me see. Yeah. So what we can do is 1 by root 2. So a by b, consider this as a quotient a by b where a and b are real. So you can write this as am by bm, right? So root 2. So root 2 1 times root 2 by root 2 times root 2. A by b is am by bm. We can even skip this. So a by b is am by bm. So the numerator will be root 2 and the denominator will be 2. Hence we wrote 1 by root 2 in a quotient form where the denominator is rational. So another example. So consider the quotient 3 by 2 plus root 5. We can ask the same question. Can we express it as a quotient where the denominator is rational? So we can use the same thing. A by B is AM by BM when M is non-zero. So what we can do is, we'll choose a suitable M which is convenient. We'll choose an M which is convenient to us. So note that 3 by 2 plus root 5, this is A by B. So we can write it as 3 times 2 minus root 5 by 2 plus root 5 times 2 minus root 5. So we choose M to be 2 minus root 5 because then the denominator will be of the form A plus B times A minus B. So this is 2 square minus root 5 square, and the numerator is 6 minus 3 root 5, right? So we get, so denominator is 6 minus 3 root 5 by 4 minus 5 is minus 1. So then we can multiply numerator and denominator by minus 1 and get, so minus 6 plus 3 root 5 as the answer. So this is a general technique. Whenever you have A plus B plus C root M kind of thing, it's natural to use so multiply numerator and denominator by B minus C root M, because then you get B square minus C square M in the denominator and the numerator becomes something else. So this is a general technique. So for 2 plus root 5, we can choose to multiply numerator and denominator by 2 minus root 5. Then it simplifies the ratio of reals to be this quantity, minus 6 plus 3 root 5. So yeah, so I think these are the basic examples, and that's all for this part. See you in the next part.